Hello guys, we are still exploring the NoneType internals in the Python, and let's see how actually the new NoneType object can be created, and actually how they have implemented the non-new method in order to get to create a NoneType object. So there's a non-new the method, and it has some error in it that NoneType takes no arguments. We can actually see this error by the calling type none and passing, for example, the some value to the type call of the NoneType. So NoneType takes no arguments. This is the exact error stated in the source code. The below they have this the macro py return none. Let's just dig into here. The documentation itself is wonderful. So py none struct is an object of undefined type which can be used in contexts where nil is not suitable, since null often means error. So as I understand the whole CPython source code, in under some circumstances, if they need some kind of undefined type, they are going to use py none struct. But don't forget to apply py incref when returning this value. So py incref is just incrementing the object reference count by 1. So when you create a new NoneType, it's going to increase the global reference count of this type. We can see this also from using the sys the module. It has some getref count and the method which is going to return the object reference count. And as help states, it's the built-in function, and it returns the reference count of the object. The count returned is generally 1 higher than you might expect, because it includes a temporary reference as an argument to the getref count itself. That's why, for example, we have declared z as none, and it has 4061 reference counts, and we have created y as none, and the reference count is increased by 1. So why the reference count to the NoneType is so high? As the documentation clearly states that there's globally only one NoneType, and every time if the CPython source code itself, so Python interpreter itself, needs some undefined value, it's going to generate this NoneType object internally, and each time it should increment the reference count. That's why it's high, as I understand. So, and as clearly the documentation states. And oops, where we have py return none. So it's incrementing the py none and returning the py none. Py none itself is a py none struct. So that's it for the simple implementation of the non-new. So we can create the NoneType from using the Python C API as well. So let's just fire up our GDB debugger, and again we are going to add brick main, then run, then call py initialize, call it, and let's see what's the type name here for the NoneType. So it's a py NoneType. So we can actually get the possible actions on this py NoneType. So there's nothing fancy here, at least almost actually almost everything is undefined for NoneType because there's no such actions we can do with a NoneType. And only the interesting part is just this TP_new. So TP_new is just calling the non-new. So we can call actually non-new directly as well. Non-new. Let's just see this non-new, which is required. So it requires as argument by type object, any type object, then the Py object, and again the Py object. So, but here in the source code, it just wants the star args and q args. I think we can pass for args the empty tuple, and for q args the empty dictionary, and for Py type any type. Let's just create one from here. Let's just call pylong new. There's nothing. No, pylong from long. It should be create the integer type for us. Then I assume Py tuple new should be, yeah, and Py dict new. So this is empty tuple, and this is empty dictionary, and this is some kind of integer. Then we can pass it to our non-new. Yeah, it, as you see that it was created, and we have a new NoneType object, but we are created it using non-new, which is TP_new for Py NoneType. Also, we have some non-deallocation here. Let's just call it. Maybe it will work, and passing the NoneType memory address itself. Call. So yes, signal aborted, non-deallocation, deallocating none. So it will raise the Python fatal Python error as clearly described here. We have also the non-bool. When you call this a non-bool, it will return 0. Let's just call non-bool and the memory address of 0. Yes, as clearly described here, the non-representation, non-wrapper. Again, it's just ignored, but still we need to pass something. Non-representation is yeah, it's not this. Maybe we should print this, and it will print a none. So it's not important here. And as you see, there's a none as number, and inside it said it has only the non-bool, the non-bool, the method. You can see this method as the bool. So none and none calling this thunderbolt. And because 0 as interpreted as false, it clearly prints the false. That's it for NoneType. So we have called non-new. The remaining thing that as a proof of concept. So we have created the call non-new, and it has this memory address. But how about the call again the non-new? So I want just describe that even calling from the Python C API, it will return at the same memory address. So none will have only one the unique memory address. Now let's just call it again and again and again. That's it. So it's because the Python struct itself has only this memory address, and it's globally unique. So we have explored the NoneType implementation. It's stored in Object-C. It has the simplest ever implementation. It's returning PyReturn none, which in turn returns the PyNone, which in turn returns the PyNone struct. And each time we are creating or assigning some none value to a variable, it's incrementing the global NoneType reference count. As seen here, it has implementation of bool type only. It's impossible to allocate the memory address of the none, because if you can do this, everything will collapse. So no need to do this. But in the next video, I'm going to change the source code to return some integers in non-new. Also, there's a non-implementation in the built-in module, which is returning simple PyNone. I'm going to return here as well the integers. So when you try to get attribute from the built-in module, it will return some integer value. So clearly the very usual things to do, but still we are brave enough to, for example, return 1, and bool none will return true. So we will do this in the next video, I think. So that's it. You might note I have nothing left for the explaining the NoneType and how it's implemented actually. And in the next video we are going to edit the NoneType implementation. So see you in the next video. Bye.